So somebody asked about the physiologic blind spot and how come we don't recognize it. Well, under binocular viewing conditions, the blind spot, so that if this was a 24 or 30 degree field, you know that the blind spot represents the optic nerve, because the optic nerve has no photoreceptors on the optic nerve. It actually cannot see anything. So the retina can see, but the optic nerve cannot. The blind spot in your visual field, in the Humphrey visual field, is represented by that optic nerve head. And so the size of that blind spot corresponds with the size of your optic nerve head. It's an absolute scotoma because there's no retinal photoreceptors there. However, under binocular conditions, the blind spot is actually covered up by the fellow eye. So you don't notice it under binocular viewing conditions. But even if you cover one eye, you like put a patch over here, you still can't see this. Now, you can prove to yourself that you have the blind spot by taking a pencil and you can just run it out laterally and it'll just disappear and it'll reappear. But your brain doesn't like to have this blind spot here, and so it just fills in the gap with the surrounding area. So even though we know there's an absolute scotoma there, you cannot make it appear in yourself because your brain just fills in the gap based on the surrounding information. So the surrounding information fills in the gap of your physiologic blind spot. However, if we do a visual field on you, where you have to press the button when you see the light, if I put the spots right there, you won't be able to see it. And that's how we tell if someone's looking straight ahead on the visual field machine. It's one of our fixation tests that make sure they're looking straight ahead. So how come you don't see the blind spot? Normally it's covered up by the other eye, but even under monocular conditions, you don't see it because the cortex just fills it in.